Dear students, welcome once again. In this unit, we are discussing various advanced plastic processing techniques. In our previous modules, we had already discussed the basic principle, process and applications of thermoset injection molding and gas assisted injection molding. In this module, we will be discussing thin wall injection molding. So what is thin wall injection molding and what are its first merits? Thin wall injection molding has been paid more and more attention, especially in computers, communication and consumer electronics industries due to the environmental and economic concerns. The reason is that the thin walled mold parts could be made lighter, more compact, less expensive and quicker because of fast cooling. Particularly, thin-walled plastic food containers are becoming more and more popular. The thermoformed disposable containers are considered to cost more of electricity, power consumption, and complex process. As you know, the thermoplastic process is two-stage. It needs the shape forming from the plastic sheet. Then the plastic sheet extrusion molding are complex too. From the sheet being heated, then it is vacuum formed and to get the product, and finally deflashing also, that process also to be carried out. So in thin walled injection molding, a specialized form of conventional injection molding is utilized that focuses mass producing the plastic parts that are thin and light, so that the material cost saving can be made and the cycle time can be shortened as possible. Shorter cycle times means higher productivity and low cost per parts. So what is thin walled? Particularly for packaging containers, thin walled means wall thickness that are less than 0.025 inches or 0.62 mm, less than 0.260 mm is called as thin walled products with the flow length to wall thickness greater than 200. Length to wall thickness greater than 200. The definition of thin wall is really about the size of the part compared to its wall thickness. For a particular plastic part, the wall thickness reduces. It is difficult to manufacture using injection molding process. So in thin walled injection molding process, it requires high pressure, high speed for producing plastics with nominal wall thickness to wall thickness less than 1.2 mm or below, and the length to wall thickness ratio ranging from, as I said, 200:1 or 100:1 or more than 100:1 L by T ratio, length to thickness ratio. It is recently developed and cost effective plastic design technology for making thin walled thickness articles like as shown in the figure. Nowadays, these mobile phones are prepared by using thin wall technology. Not only using this thin wall technology, not only save material due to the reduced wall thickness, it is also shortens cooling time, which in turn help optimize cycle time. So producing thin wall injection products also results in material saving and miniaturization. The reduction of component thickness is limited due to the following conditions: melt flow behavior, maximum injection pressure, component strength, standards under legal regulations. Now we can compare the standard or conventional injection molding versus thin walled injection molding. The key factors For conventional injection molding, usually the wall thickness is 0.08 to zero point 0.1, but in thin walled it will be 0.05 to 0.08 inches, or even less than 0.05 inches. So in machineries, for conventional standard machineries is sufficient, but for thin walled higher end or custom made machineries are required. In conventional injection molding machines, the injection pressure will be between 9,000 to 14,000 psi, whereas in thin walled it will be much higher, more than 16,000 or around 20,000 psi should be maintained. For conventional injection molding process, standard tooling is sufficient, but in thin walled better venting behavior construction is required, and more ejector pins and better polish is required. And for control systems, for conventional standard control systems is required, but for thin walled closed loop on injection speed, hold on pressure, decompression speed, screw speed are required. Now we can see how the thin wall injection process takes place. The thin wall parts requires higher injection pressure because the distance that the material can flow is dependent on the thickness of the part. In the diagram, it is shown that the material forms a frozen skin on the outside wall of the cavity first, then starts solidify towards the center. The center of the flow is last to solidify. If our wall section is very thin, then this solidification occurs very quickly. Melt stream should reach all the boundaries of mold before melt freezes, and the freezing time is proportional to cube of wall thickness. Therefore, thinner wall melt should flow fast enough to ensure that the melt fills fully before it freezes. Hence, maximum injection rate of the machine is important specification of the machine to determine the spread of the melt through the longest flow. Now we can see what are the advantages of this thin walled injection molding technique. It is cheap, safe, and clean plastic products can be obtained, and it allows faster cycle time compared to that of thin walled plastic parts, and the lighter parts reduces the fuel emission in automotive applications, and thin walled molding reduces resource consumptions and cut weights reduction, fuel usage and carbon emission. And for thin walled products made from recycled products such as PP in food applications. Thin walled products also can be made from sustainable plastics, but it has limitations too. What are the limitations? Environmental litter, like what disposable cups are being littered in the environment. This type of thin walled products can affect the environment, and high cost investment for injection molders, and also highly skilled molding technicians are required for this process. And what are the applications? The following is the applications of thin wall injection molding: food packaging, food containers and lids, and automotive, both structural and non-structural car parts, mobile communication items, for example mobile phone housings, cell phone housings, that is remote control housings, then other all thin walled products. Medical applications also, syringes can be made, and computer equipments also now made by thin walled injection molding. So with this we come to the end of this session, and in this module we discuss elaborately about the thin walled injection molding, its principle, then definition, then its merits and demerits, finally the applications of thin walled injection molding. With this this thin wall injection molding model comes to an end. In our next model, we will be discussing another interesting advanced plastic processing technique. Thank you.